Welcome to This Is My Code in New York City. I'm Matt from AWS. If you've been watching this series, you'll know that normally we focus on the infrastructure, the AWS services that power solutions in the cloud. But once in a while, we take a peek at the code that's actually running on the services. So today I'm joined by Michael J. from Slalom. Thanks for joining.
Thank you, Matt.
So tell us about Slalom. What do you do?
At Slalom, we engage with our clients to build better software. Through our product engineering methodology, we enable businesses to build software that provide the highest business value and ultimately own and maintain the product themselves long term.
Great. So you and I both been using AWS in the cloud for a number of years.
Yeah.
And we've both witnessed the explosion of serverless. And so what are you seeing with serverless development, with writing code for serverless applications in the cloud?
Well, the serverless revolution has been very exciting for a lot of people. And it's very common that developers will jump in and start writing code right into a Lambda function and sort of throw out a lot of the best practices and design patterns that we've learned over decades of good software development.
Yeah, I'm certainly guilty of that. You know, it's so easy to write a Lambda function, just kind of spit your code out there. You forget about logging, you forget about all these things that you were trained to do throughout the years. So today we're going to cover some of those best practices that you help your customers re-adopt for their serverless applications. Is that right?
Great, yes.
Okay, cool. So this is my code episode, not this is my architecture. So we have some code up on the screen that we're going to run through.
Look at that, some code.
What are we looking at here?
We're looking at a logger service class that is part of an API microservice. It can be included into other classes. So yes, we use a class structure. We use separate code into multiple files. And we're able to import this logger service into other classes to be able to output the log files.
Okay, so right there, that's a first best practice, because there is a tendency sometimes, as I've seen at customers, to just write sort of giant, monolithic, huge files. But in this case, you've separated out the logger component into a separate class and into separate project or separate files. Is that right?
That's right.
Okay. So this is written in TypeScript?
This is TypeScript, and the patterns here are really language agnostic. You could do this in C# or Java or Go or Python. The choice here we've got here in TypeScript is part of an accelerator that Slalom's developed to enable new projects to get started quickly.
Great. So you have, first of all, this class-based structure, so you can reuse this logger service class across different parts of your application. But looking at the code itself, right up top I see what looks like dependency injection. Is that right?
That's right. So that's one of the best practices that we implement here. In this case, for TypeScript, we've chosen the Inversify library. We found that works best, which enables us to use the reflect metadata of TypeScript to annotate classes with injectable and with the inject in the constructor to be able to pass in the dependencies of a class so they don't have to be instantiated within the class themselves. Great. Ultimately, this enables unit testing.
Okay, so we've moved to another best practice, unit testing. That's definitely something that I've seen people struggle with serverless. Is that the same in your experience?
That's right. A common pitfall is to say that the serverless applications are not unit testable. Okay. But we find that to not be true. They are very testable as long as you have the right practices in place and the correct patterns. So with the injection in place here, this class becomes something that's instantiatable, and we can pass in the dependencies, which can often be mocks or stubs, and that enables us to run the tests against this one class as a unit itself.
Great. So I think we have an example here of sort of the output after you run some unit tests. Is that right?
Well, let's show the tests themselves that we can write. Here's an example of a Jasmine test file where we import the needed classes, some setup in the first portion of the configuration.
Yeah, I see you're setting the region, you're setting the log level. Yeah.
Right. And the SPY setup that needs to happen before each test. And as part of Jasmine tests, these are then identified with a describe section and an it, which is the test itself. It adds the given parameter to the config secrets array. This way we can test to make sure that the log service itself is always masking secrets so that secrets don't go out into the log output.
That's another best practice. So I've definitely seen that, and we should always tell our viewers, never put secrets in your code, never put passwords in your code. And I guess this test is testing for that, right?
Absolutely.
Great. Okay, so once we test, for example, for whether there's secrets in your code or any other type of testing, what actually happens?
The output comes out into a log of the console that's running the test, which can be part of a build system.
Okay.
And here's an example of the log output. Its test run gets initiated by the NYC library. Conveniently, here we are in NYC.
Very nice.
And here shows the successful results of each of the tests with the check marks. And we'll scroll through this result set.
So you're using the NYC test library, okay.
Down to the bottom of the result here set, this library also shows coverage. And we find, yes, we can get high level of coverage with these tests. Here we're showing across the whole application of different types of classes, we're getting near 100% coverage. Found that the discrepancies off of 100% are because of compilations of TypeScript that you can't actually test.
Got it.
And here at the bottom, we show the logger service. They're at near 100% coverage.
Great, so that's the code that we've been looking at sort of thus far, but in fact, this is part of a broader project, and you're running unit tests across all of the different components of the project.
That's right.
Okay, so you mentioned something earlier that I want to get back to, and that was sort of logging to console log. Something that we've seen, which is perhaps another best practice, is not just generically logging, to have some more sophistication when you're logging for your applications. So I think you have some code in there in the early application we could look at to check that out. Is that right?
Yes, let's look at that. In the logger service, once it's constructed with its dependencies, we establish log levels, which is a standard log4j approach to identifying different levels that can be logged out to the output: fatal, error, warn, info, debug.
So is this a parameter that I could pass in if I want to change the log level from my application?
Exactly. It's part of the env config that's passed in as a dependency to this class. That enables us to twiddle that little bit in production or in the QA environment or whatever running application there is. You can change the environment variable to establish a different level of logging. Really helpful for when you need to troubleshoot problems or you need to identify a root cause of something that's happening.
And I imagine that's also helpful because sometimes people will maintain parallel Lambda functions in dev, test, and prod, for example, with different logs to console.log. But this is more sophisticated. Within the same Lambda, you could actually, or same project rather, you could actually change the log level without having to deploy a whole other serverless stack.
Right.
Got it. Okay, so how does it actually then show us the code for actually getting the logs out there, for logging?
The meat of this class, service class right here, is in the write log function, which all of the other log level functions use here. The first thing that happens, we identify the log level from the env config and default to a particular default value. And then we also serialize the error object. We find in JavaScript, error itself doesn't always serialize very well. So we get the real interesting bits out of that with the message and the stack. And then ultimately what this class does is it outputs a log object.
So this is really important. We were discussing this before, so that your logs can be searchable, parsable for later analysis. Is that right? Exactly.
Every log output is a JSON structure that has a level, the message, which is a string, the data object, which can be complex data that can provide extra troubleshooting information or extra information about the issue, the timestamp and the class name that initiated the log, along with a correlation object, which most importantly includes a correlation ID to make this log traceable through a full request that ultimately comes from the client. You can trace that across multiple APIs, multiple microservices.
That's great. So we've talked about logging, we've talked about dependency injection, we've talked about unit tests, a number of best practices. One of the things that we noticed when we were looking at the coverage earlier is you're taking your project, these are not just giant TypeScript files. You're actually dividing your project, dividing your serverless application into multiple files. How would you advise developers to structure their projects when they're using Lambda, when they're using AWS serverless services?
Great question. For that, I think I'll try to draw a little bit.
Great.
And we find that applying good design patterns across the classes that we develop help modularize this and use single responsibility. Where create repository classes, which are responsible for accessing some kind of data source. We create service classes, which ultimately will hold the business logic and the code that helps manage the other repository classes that needs to load data from.
Okay, that makes sense.
And controller classes, which in this case are responsible for the ins and outs of what this Lambda function needs to do.
Okay, so the controller is really the core Lambda brains, what it's actually doing. Service repository, that makes sense. But there's also the piece that's specific to Lambda. I think that's the handler, is that right?
Right. So the handler usually ends up being very thin, a small piece of code that's platform specific to AWS. The handler is what receives the events coming in, and those could come from an API or SNS.
Yeah, really
or
any
S3.
AWS service that triggers Lambda function,
Right.
for example.
Right.
Yeah.
And that's the part that becomes platform specific to those AWS events. The handler then uses the controller uses the service,
yeah.
the service uses multiple repositories.
Okay, and then each of these are one or more classes, which in turn are one or more files living within your project.
Right. And to package it all up, when we build, we use Webpack that brings it all together into a single Lambda file that then can be deployed as a Lambda function.
That's great. So now that we've seen how viewers and developers should structure their application, now that we've explored some best practices for how to write those serverless applications, I'd like to invite you back for another video where we actually talk about CI/CD and how to deploy these applications that you've bundled together using Webpack onto AWS. So we'll do that next time. So thanks for sharing all of this with us. It's been very valuable. And thanks for watching. This is my code.